I am Ramanathan. I introduce myself as Ramanathan, battery consultant from Bangalore, India. Today, in this video, I am going to show you how to fine-tune the tubular plate manufacturing technology. The tubular plate has been in existence for decades now, almost 100 years or more, and its production is also standardized. That you have everything is modernized now. It is all improved a lot over the years. The plate, the casting procedures, the alloy, type of alloys, everything has been improved. But still, there are some points which I would like to put across so that it will benefit the uniformity. It will improve the uniformity of the plate weight, and and it also electrical performance and life. Life also is increased. My contact details are given here. I'm going to talk to you on fine-tuning of tubular plate manufacturing technology. What are the features covered in this lecture, in this video? In India, powder filling of tubular plates is a common procedure. Most people have this procedure. Now, abroad, some of them use what is known as the paste filling. They make a paste and fill it through a nozzle into each of the 15 or 19 or 22 spines. Otherwise, the paste is taken and made into a slurry and then filled into the tubes. And the tube weave acts as a filter. The water goes out and the powder stays in. In this procedure, you get lesser pollution, less dust, and the operator is also a little more comfortable in this process. So my aim is to use the powder-filled plate to simulate the conditions of a slurry-filled or paste-filled battery. It has the benefit of curing. It can be cured, whereas a normal powder-filled plate cannot be cured. It is that facility is not there. That concentration of acid and sulphate content are so high. So I have brought down the sulphation to 4 to 6%, which is a normal level at which plates are cured. Now the plate, normally the paste-filled and slurry-filled plates are routinely cured like flat plates. Now, the second procedure I'm going to discuss is the improvement of the uniformity of the filling weight. Here I use the Hadi procedure. I'll be explaining that. The third one is the improvement of adhesion between the spine and the active material. That must be good, otherwise it can dislodge from the spine and it can become softened and it has no contact with the grid and there's no current flow. Now, the paste-filled and the slurry-filled plates have benefits of curing. It can be cured because it is a paste actually, it is a positive paste. And it gives you, what does it give you? On curing, it gives you a strong skeleton and high porosity. High porosity gives you acid irrigation. Strong skeleton gives you long life. In many developed countries, the tubular plate is made by filling a conventional positive paste or a slurry of a positive paste. The advantages are less pollution and, more importantly, the amenability to cure the plates at high temperatures and high relative humidities. Now, the conventional positive plates have about 4 to 6% sulphation. That is the quantity of acid added during the paste mixing. You see, neutralizes the PBO, reacts with the PBO, and you get about 4 to 6% lead sulphate. That is the normal procedure. We don't go beyond that, beyond 6%, because it forms monosulfate and all that, and it has low life. So this is the area we have to operate between 4 to 6% of sulphation. Then only it's a good paste. It can be developed to 3 BS or to 4 BS as the case may be. Now, on curing, a strong skeleton is built with good adhesion and cohesion and higher porosity to get better acid irrigation. This is the advantage of curing. So we should also simulate that. That will be, I will be discussing that in the next slide. Now, there is also no premature failing of active material due to this. Normally, you see some tubular plates after keeping for some time, some years, maybe it will soften. This material will soften and it will lose contact with the grid, and there is no current flow or the reduced capacity. Curing is done at high temperature and high arcs. You must maintain during curing a 10% moisture level within the plate for crystal growth. Crystals of 3Bs and 4Bs. Now, this is my procedure, modified pickling procedure to get 4 to 6% sulphation and enabling of curing. Is the main advantage. The necessary actually. We should have done this because the powder filled plate is not amenable for curing. So that is the reason why we have to do this sort of, you have to change the procedure of pickling. Normal pickling is about 12 to 24 hours, and it is taken out, washed, and dried, and then formed. Just like that. That doesn't. That has, as I told you, about 70% sulphation. Here we are aiming at 4 to 6% sulphation. How do you do this? This is achieved by controlling the duration. These are the factors which we have to control: the duration of the pickling, acid concentration, and acid volume per kg of filling material. Such plates are amenable to curing like a flat plate. It's a very great advantage. Degree of sulphation is not as uniform as in conventional plates. Paste, because it is not possible. There is no mixing possible within the powder. So it varies between 4 to 7% sulphation. Now you cure the plates at high temperature and high humidity. For further strength, you can add 2% basic tetrabasic lead sulphate seed crystals and to the filling powder, and it is pickled using a modified procedure. Now, this, as I told you earlier, you control the duration of pickling, the concentration of the acid, and the acid volume per kg of filling material. After this, after pickling, we cure it as per the Hammond procedure. Hammond procedure of curing with sure cure tetrabasic lead sulphate. In normal curing, we get 3Bs at low temperatures, 45 degrees and all that, we get 3Bs, tribasic lead sulphate. Here we are aiming at 4Bs, tetrabasic lead sulphate. So we see this can be achieved during mixing itself, but then it's a very tedious process and at high temperature and all that. It's a very inconvenient process. Therefore, I have chosen to add the seed crystals of sure cure or tetrabasic lead sulphate. Hammond recommends the addition of tetrabasic lead sulphate to the level of 1 to 3% level. Similarly, on the filling powder too, which has a particle size of some micron, few microns or less. The original TBLS, tetrabasic lead sulphate of Pennox, has submicron size, but it is marketed as a slurry to avoid agglomeration of particles. Anyhow, it is not suited for powder filling. The curing is done at a high temperature, high humidity, 54 degrees, and relative humidity of 98 to 100%. The percentage of 4Bs after 12 to 24 hours of curing can be as high as 80%. It's a very, very good figure. That is 80% of the PbO2% within the paste, within the filled material, active material, is now tetrabasic lead sulphate, 4Bs, which is very strong because it has a strong skeleton can be built with that. Also, obviously, it has good adhesion. Curing gives you anyway adhesion and cohesion of the particles. It always gives you that. Now, during curing, you must maintain adequate moisture for crystal growth. Crystals can grow only when there is water. And you need generally about 10% water is required with respect to the active material. Now, you add 4Bs in the blend using the modified pickling procedure to get 4 to 6% sulphate and then cure it. This is the procedure. Now, this is the data of Hammond. You can see two graphs. At the bottom, we have a curve which shows the 4BS content after curing in a without tetrabasic lead curve, ordinary, without the additive. You get as low as 10% tetrabasic lead sulphate you get. While if you add 1 to 2% tetrabasic lead sulphate in the paste mix, then in the paste mix or in the filled powder, you can get as high as 84%, 80% of tetrabasic lead sulphate, and that gives you the strength, the ability to withstand cycling. The longer life of the battery depends on this positive plate, and it's a very strong positive plate. Now we come to the uniformity of filling weight. On uniformity of filling weight, normally we see a variation of 5 to 10% variation in filled weights. It is seen commonly while during filling. This is the experience of many of you. Now, reason why does it happen? The powder is lost through the weave. The weave is it's a weave. So through that the hole, the powder falls out. It is like filling a tub with water while simultaneously allowing it to flow out through a tap. You open the tap, it fills on one side, on the other side, you are draining it. So that is what something similar to this is happening while filling the powder. Now, the filling jigs presently used have an aluminum corrugation to match the contour, the 15 spine or the 22 spine or whatever you are using. So it matches that. But they are not effective to prevent the loss of powder, because aluminum is a metal, it's not resilient. It cannot take the exact shape of the tube, cannot be supportive for the tube. No powder is lost. Now, Hadi uses a corrugated rubber sheet which are resilient to prevent loss. Rubber sheets are tightly fitted. Next slides, two slides are there. You will be seeing it now. No powder is lost through the weave. This is a very great advantage. Wooden cassettes of 10 plates with headspace for oxide is made, and it can be used. A wooden cassette is made. The drawing of that is given in the next slide. You may keep 100 pieces of rubber sleeves and 6 wooden boxes for continuous, seamless filling of tubular plates. This is the device. Hadi devised this to improve the uniformity of filling. What they do, they use a soft rubber, which has the same contour, it follows the tube. Supposing this is a 15 spine tube, there are 15 of them here. And this is the end sleeve, and here is the middle sleeve. Middle sleeve, touches both sides. The neighboring tube plates are touching that, and all the 10 plates or 12 plates, whatever you are putting inside the wooden box, can be held together with some sort of a device, so that it is tight. It is tightened. The main thing, the rubber sleeve is now, closely fitted to the tube and does not allow the powder to come out. So the powder is inside, and naturally the base weight is the maximum. The base weight you get, filling weight you get, as also you get uniformity from one plate to another. The filling weight is the same. Now this is a wooden design of the wooden box, just to give you head with the head space above, and the plates are arranged in this fashion with the rubber tubes in between to hold the tubes together. And this is the cut view, side view of that for 15 spine. Now in the next slide, I've given for 22 spines. It is the same way. There is no difference in design. Same design, except that you have now 22 corrugations here. This is on both sides. We have corrugation. This end plate has a single side corrugation. Same way it is done. Now this is also having a head space. Everything is the same as previous. And when you cut open like this, you can see a cross section in this manner, wooden box, top view. Now adhesion becomes important. Normally in the tubular plate filling, adhesion is not, you know, seen as a factor because there is a tube and it is tightly filled. It is hoped that there is good adhesion between the grid and the active material. This is not quite correct. It's an incomplete information. Now, spine grid made on the PDC has a smooth surface, and it is a replica of the smooth polished mold. For good adhesion, a rough surface like a moon surface is necessary. How do you get that? Is to allow the pickling acid, high pickling acid, to reach the spine. Should not be used up while, because it is a circular or cross section tube. See, the acid flows in through the sides and gradually approaches the spine. While it reaches the spine, it should have some acid. Should not be totally without acid. So you should use a higher concentration of acid that you have to work out yourself. When a battery is cut open, a smooth or clean surface should not be seen. A clean surface means there is no adhesion between the active material and the grid. In the pickling procedure, the acid should reach the spine surface. A high specific gravity acid should be used as required. Now, this is my procedure. The duration of pickling is only 4 hours in the modified procedure. This gives you around 4 to 6% sulphation. This is the main, contribution in this method of pickling. Conventional pickling takes you 12 hours and 60-70% lead sulphate. This is not acceptable for curing, not acceptable for curing. On semi-auto machines, the cork powder spray gives a rough surface on the spine. This is good. It gives you better adhesion compared to the PDC. But PDC has other advantages like tight, the high density material and all that. Now, precaution to avoid loss of materials after filling. Now, it doesn't mean after pickling, after filling, we can just take the powder and it cannot be moved around. Powder can be lost even after the plates are taken out after filling. In a closely woven tube, the small particles, fines of powder, do not readily fall. Use high density oxide to reduce fine particles. A slightly higher electrical resistance obtained with a closer view has to be accepted. This is the price we have to pay. Pickle the plates in acid or ammonium sulphate, as the case may be, in the same premises to avoid powder loss. Once pickled, there is no possibility of loss of material. The lead sulphate has a lower density and a larger size. Because the lower density means larger size. Transporting or storing the pickled plates is best done after washing, curing, and drying. There will be no further loss of material. The filled weights are more uniform. This is the greatest advantage of Hadi's procedure. Uniform material, that means there will not be any, when you charge and discharge and all that, there will not be any backward cells. There will not be any reversal of polarity on over discharge. Sometimes it happens. Many times it happens that over discharge results in reversal polarity of some of the weaker cells. So that all that will be avoided by using this procedure. Summary of what I told you today in this video: curing of the powder-filled plates like paste-filled or slurry-filled is achieved to some extent by simulating conventional paste composition. The method of pickling will give you that benefit. Addition of tetrabasic lead sulphate in the blend and curing at high temperature and high RH gives you strength and porosity. Variation in filling weight can be controlled using the Hadi procedure. the Hadi filling method I have shown you with the rubber. That's an excellent procedure. Good adhesion between fine and active material has to be ensured by curing. Thank you.